Now that we've solved one-step inequalities, we're going to solve two-step inequalities. Very similar to how we solved one or two-step equations. We're going to solve and then graph the solution step for each of these problems here as well. So the first one says 4x plus 1 is greater than 13. Right now, the very first thing that we have to do is isolate the term with the variable. And so to isolate the term with the variable, we have to use inverse operations. The inverse of adding 1 is subtracting 1. And if I do it to one side of the inequality, I'm going to do it to the other. So that 1 minus 1 is 0, those cancel. And I'm left with 4x is greater than 13 minus 1 is 12. Now I'm going to work to isolate my variable using inverse operations. And the inverse of multiplying by 4 is dividing by 4. So I'm going to divide both sides by 4. 4 divided by 4 is 1. And x is greater than 12 divided by 4 is 3. So my inequality that I'm going to graph now is x is greater than 3. On my number line, I'm going to put 2, 3, 4, 3 numbers with an open dot on the 3. If x is greater than 3, it cannot be equal to 3. So if we plugged in 3, 4 times 3 is 12, plus 1 is 13. 13 is not greater than 3, so that's why we leave this open on the 3. 3 is not a solution point. It's not part of the solution set. But any number greater than 3 is. So I'm going to shade to the right towards the 4, towards the bigger number. If I plugged 4 in, 4 times 4 is 16, plus 1 is 17, and 17 is bigger than 13. So my solution set that I just graphed makes sense. On example number 8, I've got 25 is greater than or equal to 7 plus 9d. Again, I'm going to isolate the term with the variable, so if it helps to circle it or highlight it, please do. And I'm going to use inverse operations. The inverse of adding 7 is subtracting 7. And if I do it to one side of the inequality, I'm going to do it to the other to keep things balanced. 7 minus 7 is 0, so that's why that works and cancels out. 25 minus 7 is 18, is greater than or equal to 9d. And then the inverse of multiplying by 9 to get d by itself is dividing both sides by 9. And when I do that, 18 divided by 9 is 2. Is greater than or equal to d, because 9 minus 9 is 1, and 1 times d is d. So when I go to graph, on my number line 1, 2, 3, remember that greater than or equal to means a closed circle. It could be equal to 2. But if we want to use the arrow trick, we've got to put our variable at the front. So d and 2 trade places. When they do, our sign flips around. And now we can read this as d is less than or equal to 2, because the sideways L looks like the less than, L for less than. And so if it's less than or equal to 2, that means we shade to the left towards the smaller number, towards 1. Now that the variable is on the left-hand side, the arrow also points the direction that we should shade. And so any number that's equal to 2 or less than 2 would make this inequality true. On example number 9, again, we're going to isolate the term with the variable by using inverse operations. The inverse of subtracting is adding 5, and if I do it to one side, then I have to do it to the other. Negative 5 and positive 5 make 0, so I have 4/5 v is greater than 16. The inverse of multiplying by 4/5 is dividing by 4/5. When you divide by a fraction, our rule was keep, change, flip, and so we end up multiplying by the reciprocal. So if you just want to jump right to that step where we multiply by the reciprocal, that's okay. Because the 5 and 5 cross reduce, the 4 and 4 cross reduce to be 1, and we end up with 1 times v, which is just v. And then we can put 16 over 1. The 16 and the 4 can cross reduce to be 4 and 1. And now 4 times 5 is 20, 1 times 1 is 1, so v is greater than 20 over 1, which is really the same thing as saying v is greater than 20. So when we graph this, I'm going to graph on my number line 19, 20, 21, open dot on 20 because 20 would not make this inequality true, but any number bigger than 20 would, and so this arrow, this inequality, when the variable's on the left, points the same direction that I'm going to shade. I also can read this, v is greater than 20, and shade towards the bigger number than 20, or towards the right, and fill in my arrow to graph that solution set. So So this last example is going to remind us of some of our decimal rules. Again, we're still solving for n. We're still trying to find the solution set for n, so we're trying to isolate that term by using inverse operations. The inverse of subtracting 4 7/10 is adding 4 7/10. And if I do it to one side of the inequality symbol, then I have to do it to the other. Negative 4 7/10 plus 4 7/10 is 0. Those cancel each other out. And I get 3 2/10 n is greater than or equal to 12 8/10. Now to get n by itself, I must divide both sides by 3 2/10, because the inverse of multiplying by 3 2/10 is dividing. And when I divide both sides by 3 2/10, 12 8/10 divided by 3 2/10, I get 4. And so n is greater than or equal to 4. On my number line, I'll plot 3, 4, 5. If n is greater than or equal to 4, that means that it could be equal to 4, so I'm going to close my circle. Or greater than means I'm going to shade towards the bigger number, towards the 5. I fill in my arrow. And now I know that any number I plug in 4 or bigger into this inequality will make it true. That 3 2/10 n minus 4 7/10 is greater than or equal to 8 1/10 as long as n is 4 or bigger. And so we solve two-step inequalities the same way that we solve two-step equations. We use inverse operations to isolate the variable term, and then use inverse operations to isolate the variable, and then we're graphing the inequalities just like we did in lesson number 1 for this unit, using open and closed circles and shading left or right depending on the symbol.